Hi, this is Steve Barton for Solid Rock Machine Shop Incorporated. Today I'm here with two of my sons. We have Jeremiah, we have Michael. They're learning the trade. I'm able to have the privilege of being able to teach them some of the stuff that I've learned, some of the stuff that my father taught me, kind of keep this going on in a family tradition. They helped me. Yesterday we had a couple projects that we were working on. Michael was working on the mill. Jeremiah, he was working on the surface grinder. And that was a nice thing for Jeremiah because now he's got about maybe a total of 1 hour's experience on the surface grinder. So we started with just the basics. Michael, he's been working on the milling machine. He's got about 150 hours experience on the milling machine mostly. Very little, maybe a half hour or so on the surface grinder. Jeremiah, he has probably about 80 hours worth of experience so far on the milling machine. But we had that first. We had an opportunity to train more in there. We only get the opportunity on the weekends to train, so we don't have a whole lot of time, but we're going to tackle that. We have a new item that we have for the shop. We picked up this Federal amp. We have an electronic gauge head over here, and this thing is very sensitive. It can have 3 different resolutions that you can set on this for the different degrees of accuracy that you would like. This is an electronic unit. A lot of them have batteries. This one has a transformer. And so one of the projects we had to do this weekend, we had to run some conduit and run some wiring over here. That way I wouldn't have to be going all the way to this outlet on this side. One of the things that I wanted to do is put a light switch over here that powers this right here. If I turn it on, you can see power to the transformer and off. The reason I did that is because I don't want to leave this plugged in all the time with electricity running through it, and I didn't want to be unplugging it all the time, plugging it back in. This makes it real nice and handy. I can just turn it on here, turn the power on over here, and right now I have this set at the 1/1000th increment. So from 0 over here it's 1/1000th of an inch. Come up to the halfway mark, it's going to be 5/10,000ths of an inch, and there's 10 individual marks in between there, and those will be 50 millionths of resolution between each mark. If I go to the higher or the lower resolution, it's from 0 over to here to 4/1000ths. You have 2/1000ths over here, so each mark I believe would work out to be 2/10,000ths of an inch at that resolution. We have an even fussier resolution, a 1/10, so from 0 all the way over to here would be 1/10,000ths of an inch. Coming midway, you would be 50 millionths of an inch. And because there's 10 marks there, each of those divisions would represent 5 millionths of an inch. So this is the project that Jeremiah was working on. We're just doing surface grinding on making things flat, getting a good surface finish, and he's got an excellent finish. I'm not sure if you can see that from here, but the finish is really, really awesome. And his flatness was pretty good as well. We're set on the 1/10. From here all the way over there would be 1/10,000ths, or 1/1000ths, excuse me. You have a little dial that you can dial this right in on 0, and we'll just move it nice and gently all the way across. And remember, each of those marks in there represents 50 millionths of an inch. So you can see we got a little bit of movement, but not even 50 millionths. If we turn the resolution up higher, we're set on 0. And what we're basically doing with this small diameter ball, we're actually measuring the surface roughness because it bounces. We're getting the little valleys from the traverse and whatnot. So each of those marks is 5 millionths of an inch. So you can see how flat that he has got this. The wheel that we're using is this wheel right here. It's a Ruby wheel. It's a 46 grit. We've done a video on surface grinding wheels and surface finish. Many people mistakenly think that the finer grit the wheel you have, the better finish that you will achieve. We did a video showing the surface finish, and you can get, like this, a very amazing finish with the 46 grit. If you're using a disc sander, belt sander, each of the individual grit is protruding out of the wheel, so a 60 grit wheel is obviously going to give you a rougher finish than, say, a 220 grit on there. But when you're surface grinding and you're dressing this wheel with a diamond dresser, you're cutting all the high ridges and peaks of the individual grits. You're cutting them down so that they're all on the same circumference. And so the key to a surface finish would then, with a coarser wheel, would be just a slow traverse in the y-axis, as well as how well your diamond is when you dress the wheel off. If it's cutting real nice and sharp, getting every piece of that grit at the same level. So this wheel is a good general all-around wheel. You can see it's a very open structure, very porous. And when you see that, it's amazing to see the finish that we're getting with such a rough looking wheel. If we had more of a closed structure where you didn't have a lot of the pits, still at a 46 is going to give us a lot more cutting edges that, again, when we dress it with the diamond, all those extra cutting edges will be on the same circumference and would be even smoother, and you probably wouldn't see the needle hardly move at all. When we got this meter in here, I decided that it was time to take our granite table and kind of fix the table up a little bit better than what it was. I just had it kind of setting down on there, never really had this set proper. If you look on some of the web pages where they manufacture these granite, surface granite tables, there's a method that they recommend, 3-point contact for positioning this granite and leveling. And so what we did, we made 3 discs like so, and basically the website I was on, they want you to be in the length. They want your contact point to be within 20%. In this case, it is 36 inches, or yeah, 36 inches. So we would go 7.2 inches in, and then they want you to be 20% on the width. And so you have one disc here, one disc here, one disc here, and then you would be 20% on that, and that's how we have these spaced out. Well, I wanted to pop these discs underneath the granite table, and then I needed to have a way to adjust, and so we used a 5/16 18 screw. And one of the things I wanted to do, instead of just having the screw hit on the disc, I wanted it to be able to set up so that it would actually, this disc could pivot and self-align itself with the surface there, and still have the contact point of just a single point. I have some of these ball bearings. They're 9/32 in diameter. I have a bunch of those. At the moment, it's the biggest ball bearing I have. And so what we decided to do was take these 5/16 18 socketed cap screws, and we put a chamfer on the inside there, and the ball will fit in, and it will spin riding on the angles. We have the same thing going over here. We have an angle down here. We made a pocket with a 5/16 end mill, 130 thousandths deep, and then we took a 1/4 inch 45 degree chamfering tool and popped in there an angle all the way up. So now we got a ball that pivots real nice. So what will happen is when this is mounted up, it just pivots real nice. And again, it's sitting under the table, kind of like that. It allows this block kind of to self-level and have just a 1-point contact. We have this on all 3. We fill those with some high-pressure grease in there just to make it smoother. Hopefully things won't rust. When Michael was on the mill, we had to make 3 of these, and so we made this little block, cold roll, just scrap steel. Michael, he squared that up. We inked the corner up because he had this back jaw on the vise over here and a stop set up here. So when he drilled and tapped the hole and had his digital set at 0, all we had to do was put a washer on the back here. Screwed this down real nice and tight. He can throw that back in the vise, and then he's right on the center of the screw. And then he could run a center drill in there and then a chamfering tool. When that one's done, he can pull that out, pop the next one in, and do as many as he wants. And so those are the 2 projects that the boys helped out with yesterday. Hopefully you'll be seeing a lot more of them in the future as they're learning different things. We'll hopefully be able to make videos and show you their progression. Well, thanks for watching. We'll catch you next time.